Hello, I'm back. So we're going to do the second example for the chi-squared test of independence. So this example says, John thinks that married people prefer different types of pizza than single people do, which is weird. Here's a table from a sample of adults he took in order to figure that out. So we have single, unmarried, and then we have pepperoni, sausage, and cheese. So one thing I want you to notice that's different with this question is that we are not given the totals. So that is a huge help. Whenever we go to find expected counts, we're going to need to know what the totals are. So the very first thing you'd want to do, especially like you're taking your test online, have a sheet of paper out and copy the table on your sheet of paper and then go ahead and find the totals. So I'm going to do that. I'm going to find each total row and column and then I will be back. Alright, so I found my totals. The next thing would be, we're finding, do we have evidence of the data, from the data, that marital status is associated with preferred pizza? Or that different marital statuses like different types of pizza, which is weird. So our null hypothesis would be that they are not associated, that they're independent, that married and single people like the same types of pizza, so that there's not a difference. Your alternate would be that they are associated, that they're dependent, that different marital statuses prefer different types of pizza. So marital status, the null would be marital status is not associated or that is independent of type of pizza preferred. And then your alternate would be that marital status is associated with or is dependent of type of pizza preferred. I'm not writing those out, I just wanted to say them. Your degrees of freedom would again be rows minus 1 times columns minus 1. So we have 2 rows and 3 columns. So 2 minus 1 is 1, 3 minus 1 is 2, 1 times 2 is 2. Basically the same as the last one, just happens to be. Which means, our critical value would be the same. So 2 degrees of freedom, 0.05, unless they tell you otherwise, would be 5.99. Oops, forgot the point. Right? Did I? Yeah. So we are now ready to actually find our chi-square statistic, but first part of that is we have to know what our expected counts are. So just like last time, I like to just do that in my calculator, and then, looking at my other calculator down here. So I like to do that on my calculator, but then write the expected counts in the table right next to the observed counts, just because it makes it easier when I go to do my equations later. But you can do that however you want, as long as you keep track of somehow nicely and neatly what your expected counts are. So just to go through this, for this top left column, single pepperoni, my expected count would be row total, so 102, times column total, 37, divided by overall total, 213. And when I put that in my calculator, I should get 17.7. This bottom left corner, pepperoni married, would be 111 is row total, times 37, column total, divided by 213, which comes out to 19.3. So I'm going to go through and do that really quick. Actually, I'm just going to write them in right now because I have them on my other calculator. So 28.3, this one is 30.7, this one is 56.0, and then this one 60.97, so 61.0 is how that would round. So those are my expected counts. So then my chi-squared statistic down here, I would again do observed minus expected squared over expected. So observed for pepperoni singles 20 minus expected 17.7 squared over expected. And I would do that for each cell and add them all together. Again, we have a lot of cells here that could take us a while. You can do it the slow way, but we can also kind of use our calculator. So again, I'm going to go to Stat Edit. I'm going to put all my observed in L1, my expected in L2. Doesn't matter what order you go in, as long as you're consistent and that your observed and your expected are matched up together. So I would type in those. I'm going to do that real quick and come back. So now I have those in here in L1 and L2. So I'm going to use my L3 to quickly get the chi-squared value. So I'm going up to L3, highlighting it. We want parentheses, observed, which is in L1, so second 1, minus expected is in L2, so second 2, close parentheses, squared, divided by expected, which is in L2. That gives me all my individual chi-squared values, and I need to add them together. So I'm going to second quit, I'm going to do second, stat, math, and then sum of L3. And that is my chi-squared value, 1.97-ish. So that means down here, when I did each cell and added them all together, I get 1.97. My chi-squared graph looks like that. My critical value was 5.99, basically saying that that is as far as I want it to be before I start thinking things are different. My statistic was 1.97, which is pretty far over here. So that is my statistic. My statistic is not in the critical region. The critical region is everything past 5.99. That would be my 0.05 area region. My statistic is not in there, so we would fail to reject the null, which means we do not have evidence of our alternative. So we would say no evidence that there's a difference in pizza preferences between married and single people, or we have no evidence that there's an association between marital status and preferred pizza, etc. So we do not have evidence of a major difference. In other words, there might be a little bit of a difference, but there's not a big enough difference for us to say for sure for all people everywhere that your marital status affects the type of pizza that you like. So that would be our conclusion. No evidence of a difference because our statistic is not in the critical region. As far as p-value, remember p-value is basically just the area that's past your statistic, and our p-value is much bigger than 0.05 because we're not in the critical region. So that is that. I'm going to do one more video just going through the RStudio stuff. You do have RStudio videos that are made for you, lovely by HonorX people, but I'm just going to go through the couple of things I talked about in class that are good hints and tips with working with RStudio and chi-squared. So I'm going to do that one more video, and then that's going to be it for the videos for this unit.